Hello world! Last video we talked about lists. Lists are mutable. You can add to them, remove from them, reorder them, change them. That power makes lists the most useful data structure in Python. But power has a cost, and sometimes you don't want that power. Sometimes you want a guarantee. Imagine you're storing the coordinates of a place on a map. Latitude, longitude. Two numbers. If those numbers change, you're not at the same place anymore. You're somewhere else. So you need a structure that says these two numbers belong together and nobody is allowed to touch them. Or imagine you're tracking which users have logged into your app today. You don't care about the order they're logged in. You don't care about how many times each one logged in. You just want to know who's been here. A simple list of names, but with one rule: no duplicates. These two problems, data that mustn't change and data that mustn't repeat, are so common that Python gives them their own structures: tuples and sets. Lists got the spotlight last week. Today we meet the other two, and by the end you'll understand something most Python tutorials never explain: why Python has so many ways to hold a few values. It is not redundancy, it is a vocabulary. Different containers for different rules of reality. Let's break it down. A tuple looks almost exactly like a list. Same shape, same kind of contents. You make it the same way, comma-separated values. There is only one visible difference. Lists use brackets. Tuples use parentheses. That is it, visually. But underneath, everything has changed. A tuple is locked forever. From the moment it's created to the moment Python deletes it. You cannot add to it, you cannot remove from it, and you cannot replace a single value inside it. If you want to change a tuple, you have to throw it away and build a new one. And this might sound like a downgrade from lists. Why would you want less power? Because immutability isn't a limitation. It is a contract. Tuples give you three things lists can never give you. 1. Integrity. If a value is in a tuple, you know it hasn't been touched since creation. It is the difference between a sealed envelope and an open notebook. 2. Grouping. A tuple says these values belong together as one thing. Coordinates. RGB colors, a first name and a last name. They are not a list of separate items. They are one structured unit. 3. Hashability. And this is the one most beginners never heard about. Because tuples can't change. Because Python used them as dictionary keys. Lists can't do this. Tuples can. This single property unlocks entire categories of code. Let's see all of this in action. Let me show you the difference. I'll create a list and a tuple, same data, different containers. First of all, let's create a script. Let's pass in a note and say a list, brackets. Let us create weekdays lists by saying weekdays underscore list equals square brackets. Let's say Monday, Tuesday, Thursday, and finally Friday. And then go ahead and create a tuple. First of all, let's say a tuple, parentheses, say weekdays underscore tuple equals, like we said, parentheses inside Monday. Let's just take this and copy it for the sake of making a shortcut. Alright, let's see them with our own eyes by printing type weekdays list. Secondly, let's say print again type and weekdays tuple. Save it, run it. As you can see, two different types, same data. Now, let's see what happens when we try to change them. As we know from earlier videos, lists let you change items by index. Watch. Say weekdays list and index 0. Change this to all caps Monday. And now print weekdays list. Save it and run it. Easy. Lists allow it. Now, same operation on a tuple. Say weekdays tuple and again index 0. Let's change it to all caps Monday again and print weekdays tuple. Alright. Let's save it and try running it. And as you can see, tuple object does not support item assignment. Okay, there is the wall. Python doesn't politely refuse. It throws a type error because what you try to do isn't hard. It is impossible by design. A tuple is sealed. Tuples are read-only, but reading is everything you would expect. Indexing, slicing, looping, all works. Let's clear all of these and clear the script too. Let's say coordinates equal parentheses again. It's a tuple 41.0082. This is the first coordinate, and then let's pass in the second one. 28.9884. This is the coordinates of Istanbul. Say print coordinates and index 0. This is the latitude of Istanbul. And let's go ahead and print the longitude too. Let's say coordinates index 1, the second one, and this is the longitude. Save it and run it, and as you can see, indexing works. And why not make our code more understandable? Let's just say indexing. Let's try slicing too. Let's say RGB equals 255, 140, and 0. Say x1000 amber. Print, let's pass in RGB, and then let's slice it. Start from the 0 index until the second one. Say red and green channels. Alright, let's save it and run it again. There we go. Slicing works as well. Let's try looping too for value in RGB. Let's say print the value. Save it and run it. Looping works as well. Anything that doesn't try to change the tuple works exactly like a list. This is where tuples start earning their keep. Python lets you pull values straight out of a tuple in one line. It's called unpacking. Let's try it. Let's say packing into two variables. Latitude, longitude equals coordinates. Let's say print latitude, and then let's say print longitude. Run it. As you can see, one line, two variables. Python sees the tuple as two values, your assignment has two names, and it matches them up. This is why functions in Python often return tuples. You can return multiple values at once, and the caller unpacks them on arrival. Let's shorten this. Let's make the terminal smaller and clear it. Say def get user. Let's define it. Let's say return Michael 28, and let's say Istanbul. Right, let's say name, age, city equals get underscore user as the function, and then let's say print. Use the format strings by saying f, and inside in curly braces let's say name is, and again curly braces, age, lives in, and again curly braces, city, and dot. And then just quote these out for seeing better and run it. And as you can see, Michael is 28, lives in Istanbul. 3 values, 1 return statement, 3 named variables on the other side. Without tuples, you'd need a class or a dictionary or 3 separate return calls. Tuples make this clean. Now the part that beginners almost never see. Because tuples can't change, Python can hash them. And anything Python can hash can become a dictionary key. Watch. Again, let's quote these out. Let's say populations equals, and in curly braces as a dictionary, passing in a tuple, say Turkey, Istanbul, the population of Istanbul, 16 million. Say again Turkey, Ankara, 5,700,000. India, the city, let's say Mumbai, it's 20 million as I know. Again India, passing Delhi, 32 million. Okay. Look up by tuple key, and then let's print out the populations, and inside say India and Mumbai. Save it and run it. 20 million. Look at what just happened. The keys aren't strings, they aren't numbers, they're tuples. Because the country and city together make a unique pair, we use the pair itself as a key. Try this with a list. We know that this is doomed to fail. Let's say this will fail, and then let's say broken equals curly braces, and inside the list let's say Turkey, Istanbul, and then pass in 16 million. Let's save it and then run it. Unhashable type list. Lists can't be hashed. Lists can't be keys. Tuples can, because they're locked. Immutability isn't a limitation, it's a permission slip. It is the thing that lets tuples enter rooms, but lists can't. Now the third sibling, sets. Sets come from mathematics, not from programming, not from Python. They are older than computers. In math, a set is a collection of things, where every element appears exactly once. If you say the set of vowels in English, it is A, E, I, O, U, not A, E, I, O, U, A, E, because A only counts once. That is the point. Python brought this idea straight into the language. A set in Python is a collection where every element is unique. If you try to add a duplicate, Python silently ignores it. Not because it errors out, because it's already there. Sets use curly braces, same braces dictionaries use, but with no key value pairs, just values. Sets give you 3 things. 1. Automatic uniqueness. If you need a collection where duplicates can't exist, a set enforces that for free. You don't write the check. Python does. 2. Instant instant membership testing. Is this value in my collection? Is the most common question in programming. With a list, Python has to scan every item. With a set, Python uses a hash table, same as dictionaries, and answers in one step. This is one of the biggest performance differences in Python. 3. Mathematical operations. Union, intersection, difference. Combining sets, comparing sets, finding what's in one but not the other. All of it built into the language as single operators. Let's go to the code. I'll show you the most useful trick with sets first. Removing duplicates. One line. Say a list with duplicates. Logins equal is a list. Let's say Michael, Alice, again Michael, Bob, again Alice, and finally for the third time Michael. Let's turn this into a set. Say turn it into a set. Unique logins equal set, and let's pass in logins. And then finally let's print out the unique logins. Run it. As you can see, 6 entries became 3. Python looked at the list, so 3 unique names, kept one of each. And notice, the order is gone. Sets don't preserve order, they preserve uniqueness. This one trick, wrapping a list in set, is one of the most used patterns in Python. Cleaning data, counting unique users, deduplicating logs, all of it one line. Sets are mutable, like lists, you can add and remove, but operations have different names because the meaning is different. And then in curly braces, let's say A, E, I, O, and U. Let's say add a new element. Let's add vowels dot add, and let's add Y. Let's say print vowels. Let's code these out too. Save it, run it, a new element goes in. Now remove it. Let's say remove one vowels dot remove, and let's pass in Y, and then let's print vowels. Let's save it again, run it. Gone. Now watch what happens when I try to add a duplicate. Okay, try to add a duplicate. Silently ignore vowels dot add, and then pass in a that we already have. Let's say print vowels, save it, run it. Nothing happens, no error, no warning. Python just silently keeps the set as it was because the set was already complete by its own definition. This is where the sets pull ahead of lists in real software. Watch how fast in works on a set. Let's clear all of this, clear the terminal too. Let's say a set of 10 million numbers. Say big underscore set equals set, and inside range, let's say 10 million is the number 9,999,999. In the set, they print 9,999,999 in big underscore set. Save it. Let's run it, and as you can see, it's true. Instant. Doesn't matter if the set has 10,000 items or 10 million. Python uses a hash table behind the scenes, the same structure we built our way back in the dictionaries video. It hashes the value, jumps to the right slot, says yes or no. Now compare that to a list. Let's say the same data but as a list. Let's say big underscore list equals list, and let's pass in range and then 10 million. And then let's go ahead and say is the number 9,999,999 in the list. And then finally, let's print out 9,999,999 in big list. The same logic again. Let's save it and run it. It works. But did you feel that pause? Python had to scan every single item in the list one by one until it reached the very last one, because that's where 9,999,999 is. Sets don't scan, sets jump. If your code asks, is X in this collection a lot? And the collection is more than a few hundred items, use a set, always, because that will be more fast. Now, the part that's pure mathematics. Union, intersection, difference, built into Python with single operators. For better readability, let's say users who logged in yesterday. And then let's pass in yesterday variable. And let's say in curly braces, Alice, Bob, Michael, and Diana. Let's go ahead and say users who logged in today. Let's create the today variable too. Today equals curly braces. Say Bob, Michael, Eve, and Frank. Alright, 2 sets, 2 days. Same overlap. Now, ask 3 questions. Everyone who logged in either day. This is union. Let's go ahead and print yesterday, today. Let's quote this out and save it. Run it. So, pipe, union. Everything from both days, no duplicates. Let's say users who logged in both days. This is intersection. Let's print out yesterday and today. Again, let's save it, run it. Ampersand, intersection, only what's in both. So it's Michael and Bob. Let's say users who logged in yesterday, but not today. And this is the difference. Let's just print out the difference. Say yesterday minus today. Save it and run it again. So it's only Alice and Diana. Minus difference, what's in the first but not the second. And 3 real business questions answered. If you wrote this with lists, you would write nested loops, manual checks, dozens of lines. Sets give you the operators because the math itself was already invented. Python just exposed it. So now we have 4 containers in Python: lists, tuples, sets, dictionaries. And every beginner asks the same question: which one should I use? There's a simple way to decide. Ask yourself 3 questions about your data. Question 1: does order matter? If yes, you need a list or a tuple. If no, a set or a dictionary is fine. Question 2: will it change? If yes, list or set. If no, tuple. Question 3: are duplicates allowed? If yes, list or tuple. If no, set. 3 questions, 4 answers. If you need coordinates of a fixed location, order matters, won't change, duplicates are fine, then tuple. If you need a shopping cart, order kind of matters, will change, and duplicates are allowed, then lists. This is the part most tutorials skip. They show you how to use each one, but never tell you when each one is the right answer. Python isn't giving you 4 ways to do same thing. It is giving you 4 different rules of reality. And your job as a programmer, as a problem solver, is to pick the rule that matches the world you're modeling. So, why does any of this matter for AI? Why do we always come back to LLMs? Because LLMs are made of these exact structures. When GPT was trained, the very first thing the engineers built was its vocabulary. Every token the model knows, every word, every fragment, every symbol is stored in something that behaves exactly like a set. Each token exactly once. No duplicates allowed. And when GPT looks up a word's embedding, its meaning vector, the lookup happens through a hash table, often with tuple keys. Because tuples are hashable. Because tuples don't change. Because we made them that way on purpose. Decades before AI existed. The data structure came first. AI just used what was already there. Tuples for things that mustn't change, sets for things that mustn't repeat, lists for things that flow, and dictionaries for things that map. 4 contracts with reality. Every program you ever used, including the one writing your code with you right now, is built out of these 4. Next video, we go 1 level up. We start putting these containers inside each other. Lists inside dictionaries, dictionaries inside lists, because that's how real-world data is actually shaped. And once you can compose these 4, you can model anything. If this helped, hit subscribe. I'm Hex1000, logic behind the code, signing out.